Thank you for giving me this opportunity. So here we are going to describe a little bit the process of co-development, and we are going to take as an example what we did in the INTEL-IRRIS project, which is targeting mainly the smallholder farmer communities regarding how to optimize irrigation process with a low-cost sensing system. So first, we all know that digital technology can help reducing, optimizing various usage of resources. Here, we mainly focus on usage of water, but all these technologies are very possible for large farm, but are definitely out of reach for smallholders. So this is why this is what we're going to present here: how we co-develop with stakeholders, with smallholders, and all our partners in order to reach these objectives. So what we want to have is, on one hand, a very low cost, cost-effective systems, and how to include advanced technologies that are not usually used for smallholders. And also we want to have a very autonomous and plug and sense systems to be able to be used by smallholders, small farmers themselves. So these are the main objectives of our project. And obviously, when we're talking about how to increase technology adoption, it is not only a matter of cost. We have to also consider that acceptability of technology that appear to be too complex is a very strong factor for these smallholders to not actually use your technology. So this is why co-development of the technologies is so important when you are talking with the smallholder communities. So what we had in mind and what we managed to implement is a fully autonomous starter kit, implementing the what we call the plug and sense approach, and also providing somehow intelligent irrigation in the box. And I'm going to describe how we managed to co-develop this starter kit with the various actors involved in the project. So anyway, the main result is we were quite happy to success and to be able to bring this idea into reality. As you can see some pictures here of the starter kit that has been produced and that has been deployed by the various smallholders. And we ended up with two versions of the soil devices, one with a very simple capacitive device and the other one with a more complex soil water potential devices. And the starting point of our discussion here is how could we co-develop and what could be the enablers? So what we found is, first, you need to have a simple design starting with off-the-shelf components, for instance. And then you need to have a clear or an easy integration procedure that could be reproduced by the various actors. And then you need to run technology transfer, capacity building sessions. And in order to support these technology transfer and capacity building sessions, you need to produce a lot of videos, a lot of tutorials, and so on. And on the long term, we have to worry about how generic is our platform, how easy it is to adapt to other needs in order to have long-term sustainability of your solution. So this is what we believe are the enablers in order to be able to co-develop a solution with our partners. So actually, with INTEL-IRRIS, we actually started, we took the very hard way. All the partners, took their hands, into the soldering, into the assembling, and providing feedbacks in order to improve step by step the whole process. And we ended up with various versions. We are now at the version 5. And every version brought this own improvement, and we took as many feedbacks as we managed to do. So you can see the version 2. Version 3 is not depicted here, but version 3 is a little bit enhancement of version 2. And then we switch to version 4, version 5, and each time you see that we enhance a little bit the schematic. We made the wiring of physical sensors easier for the makers. We have placeholder for resistors, which was not the case in the version 2, for instance. Then we added solar charging capabilities, and so on and so on. So we ended up with the latest version, and this is one process of the co-development on the physical sensor itself. We run a lot of capacity building events for technology transfer, and this is something that we actually saw it's working great, but it requires a lot of effort. And believe me, we have to produce a lot of tutorials, but even with the tutorials, physical presence and technical meetings and training events and hackathons are something you need to implement in order to go into any code development process. The integration was quite validated because the easy integration part of the various components is robust enough for the partners to, was simple enough for the partner to master it and to control it, and was sufficiently robust to be able to deploy the sensors outdoor in harsh environment. So this has been validated. Now, regarding how, let's say, how adaptable is a solution, let's say one proof, I mean, maybe not proof, but one insight on the, if let's say, on the success of this co-development is some partners were able to take the produced platform and develop their own adaptation. So here you can have the two watermark sensors, and another partners actually developed the 6 temperature sensors version. And some of the partners also use, but I didn't put the figures here because it's not really related to irrigation, but some partners also included CO2 sensors on our platform, and some other partners included light sensors and other type of sensors using our platform by adapting slightly the physical sensors that you can adapt, but everything else can be reused let's say, has a building blocks. We have been running a lot of piloting programs, and we have been running in Algeria, we have been running in Morocco, trying to take as much as feedback as possible. And I just want to say that the out-of-the-box deployment, I mean, the deployment was easy enough to be realized by the smallholders themselves. So regarding the capacity sensors, we had no problem with the installation. Regarding the more complex water tension, we observed that it requires more preparation and sometimes need assistance of partners or from, let's say, agricultural services, stakeholders we are working with. But we believe that with tutorials and with enough preparation, we believe that both kind of sensors could be deployed by the smallholders themselves. We also wanted to have what I call the plug and sense. So meaning that we have to transform somehow the raw data to simple aggregation decisions. So the whole process is provided by the embedded applications running on IoT Gateway. And you can see the overall architectures here. So what we develop it here mainly is the hardware platform to build the sensors, okay? And then we also building the the gateway part, where embedded application will transform the raw data to simple aggregation decision. But here also we need to have a co-development process, because when we talk about, we talk to smallholders, again, user interfaces or how the data should be presented and what data should be presented and so on, actually the choices that you really need to make in order to be able to convince the smallholder to use your technology. So first of all, the choice of having a fully autonomous gateway without any connection to internet was actually the good choice, because a lot of these smallholders actually don't have any internet access at their farm. So the ability to deploy directly the gateway just by powering it and without worrying about internet connection with 3G or Wi-Fi or whatever is appear definitely as something that was quite a good choice from the very beginning. And then regarding the user interface, we try several user interface. We, of course, have lots of try and let's say re-implementation on the user interface. But what appear, I mean, has a main principle is you need a simple interface to interact directly with the smallholder. So smallholder, they need to have they need to be able to read directly on the gateway without any devices, any extra devices, meaning without smartphone, without whatever. So this is why, you know, the small screen directly integrated into the gateway, where you have the very simple display indicating the let's say the humidity level, and the indication appear to be very, very great. But then it is also very desirable to provide multiple views for more advanced smallholders. So in case they're used to use smartphones, then we do have a separate interface that they can use with a smartphone and so on. Regarding the flexibility, the more flexibility you provide, the more parameters you need to have. But the problem with the more parameters you need is you may end up to a system that is very complex to use by smallholders. So one general rules we found is you need to provide, let's say, by default, a basic view with as few parameters as possible, and assume that a lot of these parameters could be set by default values, even if the accuracy would not be as optimal at a later step. Then you can switch to more advanced view. So this is why in our applications we do have the basic view and the advanced view. And when you switch from basic view to advanced view, actually the parameters that you can play with are completely different. So you have additional parameters. And most of the smallholders, they can actually work with only the basic view. And if they have the help of agricultural services, let's say, counselors, then they will be able to switch to the advanced view. Local languages is very important. It was quite, we hesitate a lot because we say, okay, maybe we can just stay with English because a lot of people are used to English, but definitely not. For the community of smallholders, you have to provide the local languages. So we do actually have the Arabic version of all the applications. And that appear as a good choice, because the smallholders actually use the applications when it is in Arabic, and is actually not using it when it stays in English. My last slide, can we actually save water? So it is, I mean, the last slide to show that all this effort actually have been somehow successful. So usually out of a cycle of 5 irrigation performed by the smallholders without any indication on the soil humidity level in the field, what we observe is with the indication, simple indication provided by the system, we already can save usually 1 irrigation cycle, because the soil at the root system remain humid enough for the plant to get the water. Of course, this is a very simple indication to the smallholder, but we already observed that it can save one irrigation cycle. So that concludes my talks, and thank you for your kind attention, and I give back the floor to Saif. I apologize because I'm writing in a lecture with students, so right after my talk, I have to go back to my lecture. So thank you very much.
Thanks a lot, Congduc, for this presentation. Do you have a few minutes if there are any questions right now, or you have to leave?
I can say 2 minutes.
2 minutes, if any quick questions from the audience. I have actually a question. I was wondering how you initiate this co-development process. How do you, the first contact with the stakeholders, how do you introduce your capabilities, your tools, etc.?
Actually, in these kind of countries, we have to rely on the partners that we already know. So mainly the partners of the consortium. So we have agricultural agencies or institute that are working with agricultural services. So the stakeholders have been working with them for many years. So this is through the local partners that we manage to get the stakeholders. And then this is also through the local partners who demonstrated the solution to the stakeholders, and then the stakeholders gave feedback. And this is always some kind of, we always need intermediaries anyway in this kind of co-development. It is very difficult to directly talk with stakeholders. So this is actually the experience we had in Morocco and in Algeria.